Hello, everyone. GDG Cloud Boston and GDG Atlanta are present the Professional Cloud Database Engineer Certification Workshops. This is formal session number 2 of a 12-session block of presentations. And welcome back, everybody. I'm going to switch to the next slide here. There we go. And this evening, we're going to discuss the data migration course mostly, and then give direction about the remaining weeks in the course. So let's get started. We have a lot to cover actually tonight, so let's just dive right in. Your hosts are Norbert Kremer. I'm at GDG Cloud Boston. Jessica Rudd is at GDG Atlanta. We're very happy to have you returning back to these sessions. So welcome. You can read our bio sketches on the registration site where you signed up. I won't go into all that right now. All of our sessions at GDG, all of our meetings and online sessions are governed by a code of conduct. The spirit of it is very simple: be nice, respectful, constructive, collaborative, and participate to the extent that you can. And the formal legal version of it is here at this link. These slides will be posted probably tomorrow sometime, and the video will be posted later in the week. So you'll all be able to, you don't feel like you have to take notes on all this stuff. But yeah, that's our code of conduct. So today we'll talk about where we are in the journey of our program to cover all the database topics that we want to go through. We'll go into the content review for this particular week. We'll bring up some sample questions, and we have Jessica's prepared a Slido presentation for that. We'll see a Slido poll, I should say. I hope that works. It's new to me, and we're trying to improve on our presentation techniques. We'll have time for any questions, and we'll preview any the expectations for next week and then the next 2 weeks actually. So let's just go ahead with that. Where are we in this learning path? You've seen this before. This links over to a Google Sheet here, and right there, and it's got a little more detail, but the gist of it is that we're in this very heavy beginning period of this course that has both these PDF files represent video lessons. I won't open up the details here, but there are about 4 hours worth of video lessons in the Fundamentals Core Infrastructure course, which I hope you've all completed by now. There's about 8 hours of video lessons in the Enterprise Database Migration course, and very significantly, there's about 20 hours worth of lab work in this course number 3, and a few hours of lab work in the prior course number 2. From here on out, for the rest of the course, there are actually no more video lessons. This is unusual. Most of the other learning paths have a mix of video lessons and labs all throughout the program, at least much further in than this one. So this is a bit unusual. Going forward from here, everything is lab work. And so I hope you're prepared for that. I want to, yes, okay, so what I did is I mapped these, let me go back a second. We have, if you discount course 1 and 2, that leaves 3, 4, let's see, 1, 2, 3, 4, 5, 6 courses that are really focused on our database material, right? And so we map those out on this timetable, and our numbering convention here is, we're calling this formal session number 2, which is actually week number 3. I'm sorry about a little bit of a mismatch on the naming convention here, but we're interspersing, there are 6 formal sessions, and we're interspersing an informal session with office hours in between each one. So we're in formal number 2, which maps out to week number 3 here. So we were hoping that everybody would complete this enterprise data migration, including all the labs as much as possible. Now, I know some people have made valiant efforts to finish the labs, and maybe some have, but some of the labs are difficult, and we can discuss that in a moment. We are going to move on, though, to the other courses, because if you've not completed this course number 3, we want to move on and maintain this cadence more or less to the end, so that we want to reserve the last meeting for exam prep, sample questions, and just general questions that might come up that will help you both in your learning path for other Google areas and also particularly for this exam. So we don't want to crowd this at the end, and we therefore have to maintain this cadence. And so we're going to move on from this 3. I recommend that if you're not finished, you can come back to it later, or even after we finish the whole workshop series, you can come back and do it on your own. But we do need to move on, I'm afraid. So, so with that, I go into the content review for this session, which is, these are mostly Google supplied. Google supplied quite a lot of slides for this week. They don't always. It's been a little bit uneven in what they've provided us. So I'm filling in a lot of additional topics. And if you were on the meeting last week, you know that was mostly my own material. And for the informal sessions, there's no Google supplied material. So for this week, we have quite a lot. It's focused on this enterprise database migration, which is course 3. And I think this goes right into it. So I want to pause here for a moment to see if people have questions about the labs, or if anybody wants to volunteer how their progress is with the labs. We could look for that in the chat, or you could just open your mic and tell us. I want to see if a couple of people are attending that have been active on Slack. Okay, I see that Lawrence is online. I know you've been active in chatting with me about the Oracle Bare Metal solution lab. Were you able to finish it, or how did you end up with that one?
For the Oracle one, all officially is finished, because when I check, there's a checkpoint. Everything's turned to green. However, I think that checkpoint is pretty lenient. I wasn't able to bring the Oracle database all the way up, just because I believe that Ansible script keeps on. Well, I won't say Ansible script issues. It's because the SSH keeps on timeout.
Okay.
Once it times out, I think somehow Ansible doesn't know how to complete it, but eventually it completes. What I did is I go back in, log into that Oracle VM, and just do a top. I can see the Ansible still running in the background.
I see.
Until I wait for it. I wait Ansible just run to its completion. That means when I do a top, Ansible process is gone. Then I start to make the connection to it. But once I try to make the connection to it, it's looking at something. I don't believe what that is, but it basically looking for some connection, but it says it's not available. And that's what I got stuck. But however, if I just do the checkpoint at that moment, and it turns, it says it turns to green. So that's what.
I see. So let me give a little context, because well, first tell me, how many times did you attempt the lab to get as far as you did?
So initially, it's just because of copying issues.
Yeah.
It's just taking so long.
Yeah, I'll explain that in a minute.
Yeah, until you provide me that call, and
Yeah.
call. Well, even that call is still it initially taking about, I think it's 30 minutes or so.
Mm-hmm.
Then on the second round, you give me another call that takes a lot faster. It's done within 10 minutes. Then I start to use SCP to copy from the Bastion
Right.
VM over to the Oracle VM. And that takes another 20 minutes or so, even though within the cloud itself. But then also then you also give me the suggestion use the rsync. Rsync is a lot faster. It's only 2 minutes
Yeah.
on
Yeah.
top.
So did you
So
ran it, I think, 5 or 6 times altogether?
more than that.
More than that. Okay.
Yeah,
Okay.
I run it probably 8 times.
Yeah.
So
So let me summarize it for the rest of the group. There's a lab which is called Oracle BMS or Bare Metal Solution Lab, and the steps you have to do according to the lab are you have to sign up to Oracle TechNet OTN, create an account, download some software basically download the Oracle database installer from Oracle, because Google doesn't want to touch that software because it's not open source software. It is Oracle licensed software. You are allowed to download it under the terms of the TOS of Oracle, which you're agreeing to when you create an OTN account. Okay, so Google doesn't want to have anything to do with that, but we are allowed to do what we're doing. So, but the thing is, it's technically very tricky to sort of capture the download and redirect it over to Google Cloud, which is what they want you to do. And you have to do this all within the time limit of the lab. And it takes, it might depend on your bandwidth and your connection speed and things like that. And it could take potentially many minutes, close to an hour, just to do the file transfers. And meanwhile, the lab clock is ticking the whole time. So it's, under best of circumstance, it's a very difficult lab to get it done. The trick that I discovered last year when I did this is I created a bucket on my own. I created a bucket in my own Google account. I downloaded the software from OTN onto my laptop, and I pushed it up to my Google Cloud bucket, which I own, right? And then once I got into the lab environment, I used assigned URL, or authorized URL to grab that file over, and then so cloud to cloud it goes much faster than it does by the other method that Google wants you to do. So I think the point of it is that and then Lawrence did quite a few attempts to after we got the software going, and I gave him a bucket, basically. I gave him a bucket in my Google Cloud account, which would end up costing me a nickel or something like that. So it's not, if anybody else wants to do that, I'll create a bucket for you. We can do that. But the point of it is, it's a very difficult lab at best, and you may choose not to do it, or you may just, if you choose not to do it, I would just read it through a couple of times so you get the point of it. As Lawrence found, even when he got through some of the difficult downloading steps, it still was not, he wasn't able to finish it all the way as written, and he was still able to, do the progress check and get credit for doing it, but it wasn't completely satisfying in the sense of, oh, okay, I got to run every step in the lab as written. Now, I think you also, I don't, no, I'm sorry, I'm thinking of someone else. Enoch also was posting on our Slack channel this week, and he ran into a couple of issues, and I wasn't that immediately familiar with all the steps in that particular lab, so he created a support ticket which is in the within the learning environment within Skills Boost. There's a you can click on a button and open a support ticket. That's what I recommend that you do. I think he maybe started with a chat support ticket. They usually can't resolve the issue on the chat immediately within a few minutes, so they're going to end up getting back to you anyway. So for that reason, I recommend actually just starting with an email support ticket. and they will get back to you. Sometimes the support ticket can be helpful. It does a couple of things. It alerts them to the idea that this particular lab is challenging, that, if they get a lot of tickets on one lab, they're going to take a look at it. So even if it doesn't help you directly, it does help the overall process. And it helps the curriculum developers maybe take another look at that lab and see that, all right, there's one particular step here that's causing a lot of problems, and maybe we can improve that. And I actually suggested that on this Oracle lab, that they would have a better way of downloading the software and getting it up to Google Cloud, because it's very cumbersome the way they've recommended doing it right now. Now they haven't changed it. It's the same as it was last year when I did it. So I definitely recommend either creating a bucket on your own or asking me for help on Slack, and I'll give you a bucket. I'll loan you a bucket from my account. So it's easy to do that, and it doesn't cost very much. So it's certainly not a problem for me to do that. But so I guess the larger point is, I don't know how far everyone has got through the labs, or what their goals are for this whole learning path. But I think there's a trade-off in, you have to look at each lab, and like a very difficult lab like this Oracle lab, you may decide, okay, I get the idea of it. I'm not an Oracle DBA. I don't want to become an Oracle DBA. I'm working with Postgres or something like that. You may decide, okay, I'm not going to take that lab on because what I'm going to get out of it is too much effort for what I might learn from it. So there's always a balancing. And Jessica, do you want to say anything about the skills tracker at this point, or do you want to wait until another moment for that?
It's not really set up right now, I don't think.
Okay.
The only thing I would say was, and I don't think we should spend any more time on this. It's a perfectly reasonable conversation to have in Slack. But I don't plan to do the lab at all. It's like not even really covered on the exam. And I wouldn't tell anybody to ever be an Oracle DBA under any circumstances, unless you literally hate your life. So
well, that's a different topic.
Yeah, it's a different topic. So don't ever do that. Maybe it'll be different now that they have a supposed partnership with Google and something, but I would just say read through it and understand what's happening and call it a day. Unless you really want to see the green check boxes, and then have at it.
Yeah. I mean, I stuck through it. I did it. I think I did it 3 times, and I was successful on the 3rd try. But I have a lot of experience with all this stuff, and it's definitely not something that you would just fly through on the first try. And I'd be very surprised if you did, or if maybe you get very lucky. But so. All right, well, unless there are more comments on people's progress with labs or questions with labs, I'll go into the review part of the presentation this evening. Okay, going once, twice. Okay, here we go. So we're talking about enterprise databases. Also, this is the introduction to the course. So there's a lot of kind of general learning about database and migration within this first course. That's why it's partly why it's a very heavy course. The point that's being made here is that if we look at, now when they say over on the right side, when they say least difficult and most difficult, that refers to migration. It's not how challenging it is to build these apps or to run a database. That's referring to the migration difficulty. And so what you have is going back on the left side, what we have is the client server architecture, which became prominent in the 90s, in the mid 90s and late 90s. We have this either called client server or 2-tier architecture, where clients would talk directly to a database. This was before the internet was widespread, right? So you had inside companies, you had intranets, and you typically would have a database database client. Could be something. Well, Power Builder was very popular, for example, and with Power Builder you could talk to an Oracle or Sybase backend. So that's a two-tier approach. And as the internet became very prominent, we moved to this three-tier architecture where we had application servers at the late 90s that were the app servers had objects on them that managed the access to the database, and the client talked to that object, and that object had the business logic in it, and the object would then make the appropriate calls to the database server and retrieve the results, get the results back, and send them back to the client. So we have this kind of three-tier architecture. It was able to scale to larger number of clients. That was one of the big drivers for it, and it also worked over the internet, whereas the two-tier approach did not work well on the internet, on the public internet. So later we evolved to what we have now is some version of service-oriented architectures, where we have pulled this what we used to have in the app server. We pulled these connections that, so actually build a service now, or build a microservice that resides on a web server. These could be REST APIs, or they could be other web services that receive calls from clients on the left. We're explicitly calling out a firewall here, and then so that web server is out accessible by the public internet, and then we have a firewall, and that firewall protects the database server. So why is it more difficult to the further back we go? Why is it more difficult, or why is it easier to migrate today typically? And the reason for that is because the business logic is very much in the client server era. We had a lot of business logic in the database itself. It stored procedures, and that code became really part of the database itself. So if you need to move that, the database in that era, client server era, consisted of tables, indexes, and then a lot of stored procedure code very often. And that made things much more complicated to migrate. So if you're, as we'll get to in a minute, a migration can take on one of several forms. It can be either migrate to the same platform, go from on-premises to the cloud, but keep the same database platform, or a migration can also involve moving to a different platform, let's say from Oracle to Postgres, for example, and also at the same time move from on-premises to the cloud. And so if you have the situation where you have a lot of business logic wrapped up with your database, tightly coupled into your database, that makes it more challenging to migrate under any scenario. Now it gets a little easier when we have this three-tier approach, where we have the business logic is on an app server. At least the database part itself can be migrated relatively seamlessly by itself, and then we have to worry about how to move the application code to some new home in the cloud as well. And so, but at least we have, for the most part, pulled out the business logic, and a lot of that's now in the objects in the app server. And the same thing as we go to the service-oriented, it becomes even more so. There's decoupling of application code. Business logic is decoupled from the database itself. So that's why it becomes a little easier as we go to the more modern architectures. Now, there's still a lot to it. Which I'll get to. I'll come back to that in a moment. So this is a bit of a detour here. I don't want to spend a lot of time today to talk about these points, because we're going to spend a lot more time in the future weeks and in the coming weeks on these. Google has 6 or 8 different database products, and choosing the right DB for each type of requirement is not a small task sometimes. So we'll go through this as we begin to talk about the other products. For the moment, we're talking about relational databases only in this migration section. I don't think any of the labs discuss moving a NoSQL data store. They're all relational, DBMS of some sort or another. So we talked about Oracle, we had MySQL, Postgres, and so forth, but they're all relational DBMS, right? So in other words, we're all entirely on the left side here. We'll talk about the properties of these databases and what they're good for, and what ACID means, what referential integrity with foreign keys. We'll talk about all that later. But just to give you a preview of that, there are these a whole other class database servers that are called NoSQL, and they have their own wonderful properties. And you give up out of things on the left side here. You give up ACID, for example. If you need ACID, then you're going to have to come back and use one of these databases on the left. But sometimes you don't want that, and it gets in the way. So we have NoSQL. And then finally, as we've mentioned a couple times, there on the far right, we have for large analytical workloads, we have build data warehouses, or sometimes called enterprise data warehouses, and BigQuery is the main product in this area. We will not be discussing this much because in Google's world, BigQuery is not classed with the other database products, right? It's considered an analytic product. So it's actually something we don't talk about very much at all in this whole learning path. And there is a data engineer learning path that does cover that very extensively. While we're on this slide, I do want to point out that when they talk about object storage over here, that means Google Cloud Storage, GCS, or Cloud Storage is what they mean by object storage over here. Do not confuse that with object databases or object relational databases. And Postgres, for example, is a good example of an object relational database. And what object database means in that context is that you can have tables in Postgres that have child tables that inherit from parent tables. So you have inheritance and polymorphism, and you can have some interesting properties around that. That's completely different from what this is talking about over here, object storage. So I don't want you to be tripped up by that or think that they're the same thing. You'll also see the word blob sometimes. Sometimes object storage is called blob storage, as it is in Azure, in Microsoft Azure Cloud. They refer to their storage, their equivalent of Google Cloud Storage, they refer to that as blobs. And again, those are the same types of objects, but they're not database. They're not object database, right? Object database was something that people thought would take off in the around 2000s. Never really got to be too prominent, but Postgres does have some features in this direction. So enough of that. Yeah, let's see. Okay, good. So in getting back to migration, let's understand what the different types of databases are that you might be migrating. So you're starting typically with an on-premises database, and you want to move that to the cloud so that we can get better business agility and perhaps some cost savings. Although that, it's difficult to achieve cost savings in all cases, but sometimes we can do that by moving to the cloud as well. So let's dive into some of these. Again, the focus of today's presentation is not to discuss all the various differences of all these different types of databases. Sometimes these are called storage, different types of storage within Google Cloud. I tend to think of them as either relational databases or non-relational or NoSQL data stores. And but I don't want to drill into all the differences because we're going to talk a lot about that in the coming weeks. But what I do want to point out on this slide is that the database migration service is broadly available across pretty much every option that you have up here. These are your targets, right, that you're going to. And now you could be coming from lots of different things, but the point is that these two rows on the bottom are telling you that the data migration service and data stream, which you've worked with some of the labs, these are broadly available across every type of database that you're moving to in Google Cloud. Now, this row here indicates that some of these are managed as, you know, database. So they're called third-party database engines, meaning that if you have Cloud SQL, it's really built on one of these other products from MySQL, Postgres, or Microsoft, right? So Cloud SQL is a managed service that runs one of these things for you and takes care of, gives you a lot of automation around backups. It gives you auto matching that you don't have to worry about, things like that. And likewise, AlloyDB is built on Postgres. Bare metal solution we've talked about is how you run Oracle in Google Cloud for now, at least until they come out with the partnership arrangements and so forth. But these are all a group of managed third-party database engines. Now, the ones that exist only within Google Cloud are these three on the right. And BigQuery would be here as well, except we're not discussing BigQuery in this learning path, right? But those would be, there's Cloud Spanner doesn't exist anywhere other than in Google Cloud. It has a interface that looks like Postgres, but it's not Postgres by any means. It's much more powerful than Postgres itself. So, although it's based on it in some way, it's very largely different, I would say. So, and it exists only in Google Cloud. You can't find Spanner anywhere else. The same thing with Firestore, exists only within Google Cloud. Bigtable per se exists only in Google Cloud, but you have equivalents of it you could build an HBase. There's an Apache open source project called Apache HBase that is very similar and comparable to Bigtable. And so that would be kind of put an asterisk on that one and say, okay, it's existing only as Bigtable exists only in Google, nowhere else, but you do have an equivalent that you can run elsewhere. But you'd be running that yourself, not as a managed service. Okay, so that's the point of this slide. Okay, one of the things that you may have noticed in some of the labs is how we architect for high availability and scalability in the cloud. And one of the main features of moving to the cloud is that it's much easier typically to create an HA solution. It's certainly easier to test it. It's easier to spin up alternative environments like dev and QA and test environments, destroy them when you're finished. That's one of the main advantages of moving to the cloud. It's why we get improved business agility and improved ability to experiment at low cost in the cloud. But what is it about the cloud? What features of the cloud actually make this happen? How do we architect for high availability and scalability? Well, we haven't discussed it in great length so far, but all of the cloud service providers arrange their data centers in regions and zones. I hope this would have come through in the course 01, the fundamentals course. Let me reiterate it here though. A region, think of a region as a city or a metro area, and think of a zone as something smaller than that. Like, and I'm being a little non-specific because Google, in fact, is very, in general, rather secretive. All the cloud providers are rather secretive about exactly where their data centers are. Some of them are well known for some reason, like Google West 1 is in Dallas, Oregon. You can look it up on Google Maps and it says right on their Google data center. You know, it's really obvious. I don't know, the other ones are not so obvious. But so again, a region like I just mentioned, US West 1, has multiple zones within it. And the zones might be in a building that, like zone A and zone B might be in two buildings that are very close to each other, or they could be separated by some perhaps miles. And that's not, the exact distance is not important. What matters is that the zones within a region are in separate failure domains. And that means they're fed by separate sources of electricity. Maybe each zone has two independent sources of electricity, but the different zones would not share the same substations, or they would not, they'd be on separate cables, separate wires. They'd have separate backup generators. And the same with internet connections, air conditioning, and water supplies for air conditioning, right? These would all be completely separate, so that if you have a failure in one zone, it doesn't cascade into the next zone. That's the whole point of having zones and arranging the data centers in zone. So don't think of it as physical proximity, but think of it as failure domains, separate failure domains. That's the important part of a zone. Now, the regions are deliberately not too close to each other because for those customers that need a much greater level of resiliency than you get from zones, from having multiple zones, you might say, well, I want to have two data centers for my company, for my enterprise, and I want them to be fairly far apart so that if a hurricane, for example, comes along and wipes out an entire region, I don't want it to impact my second region where I've had my second data center. And so, for example, I'm thinking of two data centers in the East Coast of the US that are Google data centers that are fairly close to each other. There's one in South Carolina, and they're called, I think that's US East 4, and the other I'm thinking of is in Virginia. That's US East 1, I think. Don't quote me on these numbers, but they're South Carolina and Virginia are fairly close. Conceivably, those data centers, those regional resources could both be taken out by a single hurricane, for example, or something like that. So if you wanted to have a primary and a backup, I would choose something further apart than those regions, right? I would say South Carolina and US Central or US West, for example. That would be a common pattern. So why do we, the other key point here is latency. So latency matters a lot when we talk about, depending on the solution that you're building, right? If you're counting on replication, database replication, you don't want to introduce a lot of latency into that. So latency zone to zone is 1 or 2 milliseconds, a couple of milliseconds maybe. Latency region to region is tens of milliseconds within one continent, or it could be hundreds of milliseconds globally, right? So, and that's just for one round trip. So you don't want to introduce a lot of latency. I think I'll come back and say more about this later, but because we do talk, each of the database products has different modes of achieving high availability. The primary thing that you should be focused on is the first go-to solution is to build a service overall that has resources in 2 zones. That's going to handle many, many situations. There are a few companies that need to handle an outage of a complete region. So they would want to build an HA solution that replicates data from region to region. But that's already becoming more of a rare scenario, and it's more expensive, and it has longer latency. And so it's not something you want to just jump onto right away. So you start with like a zonal outage. Let's say US West 1 zone A went out. That could happen with a certain frequency. So zonal outages are the most frequent, and they're also the least expensive to work around, to have a backup for a zonal outage. When you go up to the regional outage, it becomes much more expensive to build multi-region solutions, and the frequency of an entire region being out is much less. So it's a less probable event, and you're paying a lot more for that protection. So it's a kind of insurance policy, but you have to know what your risk is and how much you're willing to pay for the insurance. Now, if you take it to the extreme, you could say, well, all of Google Cloud could be down, right? It has happened, I think, for each of the major cloud service providers. They've had brief times when the whole cloud has been down, whether it's related to DNS or something fundamental like that. Probably that's usually the reason. But it has happened, and it can happen. It could happen again. If your company is so critically dependent on having, web servers running every second of every day, no matter what happens, even if a whole cloud goes out, then you could back up across 2 clouds, right? You could build an HA solution across 2 clouds. That, again, is a much more rare event, and your solution that you build for that is much more expensive. So again, it's like, what's your risk? What are you insuring against? And how much do you want to pay for that insurance? Okay, so that's where this HA discussion really needs to be focused on, is kind of a risk calculation. Now, the second point here is, how do we achieve scalability with relational databases? So we'll talk later about how NoSQL databases handle this, but the fundamental difference is really the third bullet point on this slide. With our relational database management system, right, relational DBMS, the pattern has been historically, this goes back to when Oracle and Sybase and MySQL and Postgres were all getting started, maybe in the 90s, 2000 era. If you needed a more powerful database, meaning you had to handle more writes typically, or more reads, but especially writes are often the limitation. Okay, so if you had to write a higher number of transactions per second, the easiest thing to do was just scale up, meaning you went to a larger server, okay, and you would go from, back in that era, the servers might have 4 cores or 8 cores, and so you double. If you need a larger server, a larger database, you would double it up and go up, by factor 2, go up to 16 cores, something like that. Well, in the era of internet scale applications, that doesn't really work anymore, because I forget exactly what the largest available server is on Google Cloud, for example. I think it might be 96 virtual CPUs. Could be a little higher than that these days, but you hit the limit somewhere where it's either becomes very difficult to get larger and larger servers in the cloud, becomes difficult, or it becomes very expensive. And in fact, on premises, it also becomes very expensive, because larger servers with very high core counts, you also create a single point of failure at that point in your architecture. So then you have to buy more expensive servers that are built better and more reliable. And that's not the pattern of the cloud. The cloud is to use commodity hardware as much as possible and to stay less expensive per server. Okay, so this is why scaling up works to a point with relational DBMS, but one of the drivers of the NoSQL movement that we'll talk about more later is the ability to scale out. Scaling out is very much a cloud native idea, right? You've seen this already with, if you're running VMs and you go to a managed instance group that's auto scaling, the way you add, if you have a web server farm, the way you add more capacity for your web traffic is to scale out and add more web servers. That's very much a cloud oriented thing. The whole idea of containers, of just, of starting more containers as you need them to handle more volume coming in, is very much a cloud-oriented thing that Google and Amazon and others have pioneered. So that's the trade-off between scaling up, scaling out. It is still the case today that, for the most part, relational DBMS, if you need more write capability, you would do that by scaling up to a certain point. If you get to the limit, then it's time to move over to Spanner. Spanner is built for this use case where you have extremely high demands. It's relatively expensive. It can be expensive. It's expensive at the low end, right? If you have small data volumes, Spanner would not be a good choice because the minimal cost of running it is fairly high. This is a point that Glenn made a couple weeks ago. If you get into the volume where the other systems don't do well, they're hitting the limit on scalability, then Spanner becomes very cost effective. So I'm not saying it's expensive overall, I'm saying it's expensive at the low end for the use case that it's not designed for. Okay, let me talk about, okay, I'm going, on my slide here, I'm going from bottom toward top here. So we'll talk more about how I've been focused on write performance, but we also have a situation where read performance is a lot easier to handle by replication, because it's fairly easy to make copies of data. If you have one database that is so-called leader or primary node, that's where you're writing to all the time, except for when it fails, then you can fail over to one of the read nodes, the read replicas. And so these are called active-passive mode, active-passive standby mode, where the second server is in standby mode. If the primary fails, the other one can pick up the writes, and you have to redirect, obviously, use DNS to redirect the traffic and things. That's where the load balancer comes in, is to see, you'll have a health check on your load balancer. If the health check fails, redirects traffic to the other, what was the read replica now becomes the primary node. Okay, so that works really well. That can help scale reading a great deal, and that can help with both volume and also geographically. If you have, let's say your primary database is on the East Coast, but you also get a lot of read traffic from the West Coast, you could replicate to a database server on the West Coast and redirect the read traffic to that West Coast server, and that would take a lot of the load off. And to some extent on the primary node, there's a competition between reading and writing. So if you can offload the reading, that helps with the writing indirectly. Okay, so I'll say more about this with the individual products as we get to them. I want to mention sharding. What sharding means is that you separate different blocks of data, either sometimes to separate tables on the same database server, but more typically to different servers. So if you had a customer user base that got to be too large for a single server, and you didn't want to scale up anymore, or it was too expensive to scale up, or you couldn't scale up, there just aren't anymore, there is no larger server to scale up. And you could then go into the sharding approach. I would say that any sharding scheme where the developers have to be aware of the sharding is a nightmare. And whatever Jessica said earlier about Oracle being an Oracle DBA, I would say if you see a solution that involves sharding where the developer has to be aware, just turn around and run away. Just go home. I mean, it's just there are lots of horror stories about how people built these things at large scale, and they just are really difficult to maintain. And so what I mean by that is, let's say you have customer database and you say, well, customer A through E will be on database server 1. F through N will be on another server, and another group of customers will be on the third server and the fourth server, and so on. And then if you have to be aware of that, if your code if your web code, your business logic includes things like, if customer name starts with C, go to this server, that's a disaster basically waiting to happen. It's difficult to maintain, it's hard to test, things are going to go wrong. It's just not a great solution, in my opinion. I don't know, Jessica, do you have a different take on that at all, or a different experience? I've heard nothing good about that.
No, yeah, it doesn't sound
Fortunately,
logical.
never worked on it.
Yeah.
Now, having said that, sharding is used behind the scenes by Google Cloud Spanner, right? So, but it's completely invisible to you, and it's managed by the server transparently. You have no need to concern yourself with the details of it. So you just have customer A through Z, wherever they are, you just write it to the customer table and you're done. And that's fine. I'm not saying anything about that at all that's negative, nothing negative about that. That's in fact, so by sharding, we mean separating different pieces of data or different chunks of data to different servers or different disks or different locations, that kind of thing. So as long as it's handled automatically by the system, it's fine. If you have to get involved in as a developer and worry about that, I would really, really try to stay away from that. Okay, enough of that scalability discussion. I happen to be passionate about scalability in the analytics and data warehouse world, so this is something that's very close to my heart. But let me go a little bit. This is summary now because I've already talked through these points, but let me summarize what I've said. When we get into details of, this is my slide, the previous material was from Google. When we're architecting for high availability and scalability, consider the details. When we go intra-region means within one region, meaning zone to zone, zone A to zone C, B to C, A to B. The latency is a couple of milliseconds, and that can work really well. That's not too big a hit, so we could write to the primary node. We could have a read replica that will be caught up shortly thereafter. That makes it possible to have a synchronous replication. In some cases, we would have to have asynchronous, or we could choose asynchronous replication, but there are trade-offs involved in that, and I'll get into that. So if you must have the ability to tolerate the outage of an entire region, then you have to build a solution that has inter-region, in other words, region-to-region replication. Then the latency is going to be tens of milliseconds, because you by design, you don't want those regions to be right next to each other anyway. So it would have to be at least 100 miles away so that you have really strong independence of outages. Let's say there's a grid outage, electric grid outage, things like that, or a hurricane. Think of these large natural disasters that could affect two regions within 100 miles of each other. So by definition, you'd have the regions fairly far apart. Your latency is then tens of milliseconds within one continent. You are then have to take that into account. You probably do not want to use synchronous replication in that case, because every time you write something to your primary, you're going to have to wait for the acknowledgement from the secondary, and that's going to be too long of a delay for that. So that's the trade-off that you're making here with the latency, whether you whether you need zonal backup or regional HA. That's the kind of thing you get into. The links I've put on here, I think we have a lot to cover tonight, so I want to keep going. There's a map of the Dalles, Oregon, US West 1 region. It's interesting to look at the map. I just want to call out that if you look closely on the map, a little bit to the north of where the data center is identified, there's a whole lot of construction going on that I'm speculating is a new extension to that data center, because what I see there are a lot of air conditioning fans, and I see like an electric substation. And the things, if you're looking on a map for a data center, you're looking for air conditioning, cooling towers, and huge electric substations because they consume many megawatts of power. And so I think they're building out this region even more so than it is, because they're supporting the new demand driven by AI. And I'm speculating on that. But if you want to know if you're curious about your ping times from your location to all of the Google Cloud regions, there's a tool here that will do that for you. There's also documentation within Google Cloud over here on this link that has the ping time between different Google Cloud regions. And it's on the order of 10, like I said, tens millisecond to up to 100 maybe within the continent, and goes up from there when you go transcontinental. Okay, scaling. I want to give, I just want to call out PostgreSQL, Postgres, however you pronounce it. It's a good example to study because it has different methods of adding replica servers. I've been chatting about synchronous versus asynchronous. Postgres gives you both options. You can set it up in different ways, and it's an open source product, so you can download it. You can experiment with it at low cost. It's a great way to learn about this stuff if you're in doubt about how it works. The trade-off is here. There's on this link. There's actually 3 levels of risk that Postgres has identified, and again, this is how trade-offs work, right? The lower your risk of data loss, the worse your write performance gets, right? So I'll just give you the 2 that I've been talking about, right? The synchronous versus asynchronous. If you do an async replication, the primary node acknowledges that it has written to its local disk, and you send the commit back to the client. Say, okay, I've got it. I've got your data, good to go. And then the replication follows as soon as possible afterwards. But there is a few, maybe tens of milliseconds or less than a second, let's say, where the primary has received it, but the secondary has not yet received it or has not written it to its disk. So if the primary fails in that precise moment, you could lose that group of transactions. Okay, so if you make it synchronous, you lower the risk. And then there are 2 kinds of synchronous replication, and you can choose your risk level that's acceptable to you. But Postgres, this link here and the Postgres in general are a really good way to study this, because Postgres actually has brought in a lot of features over the years. It's a really high quality open source database, and I've liked it for many years. I'll stop there, but I really do like it a lot. As I said, sharding mentioned. If you have to be aware of it as a developer, it's not a very desirable solution. You should be thinking about Spanner at that point. If your write volumes are so high that you can't scale up anymore, you probably would be thinking about Spanner anyway. So it's time to get out the cost calculator, figure out what it would cost you to migrate to Spanner, and also run Spanner. Like what's your TCO over the next 3 years? That's how you do a projection. Look out over 3 years, figure out what your cost is going to be. You probably want to do that rather than take that pain of being constantly aware of the sharding methods. Because the problem with the sharding thing is, if you have to be aware of it, it can change over time. Like the balance of, you know, you may not get the balance right. You need to rebalance it. Then you're changing your sharding logic inside your code. This is why I don't like it. Okay. There is, I'll give you an exam tip here. There are certain tip-off phrases, call them spanner tip-off phrases. If you see a requirement ever that says you need a relational database that has very high availability on its own, right? It's a managed service. You're not thinking about how it does it. You just talk to your local spanner interface. You send your data over there. You wait for the commit. But if you're looking for 5 nines availability, 5 9, it should be, I wrote SLA, it should probably be SLO technically. But if you're looking for 5 nines availability, you should automatically think of spanner right away, because 5 nines is pretty hard to achieve in general. In our lives, as we go around living in a city, it's pretty hard to get 5 nines on anything. A good example is telephone service. I'm talking about traditional landline phone service. That's usually 5 nines. I cannot think of a time. I can think of one time in my life when I picked up my phone and did not get a dial tone, and then I looked outside my window and I saw that a tree had fallen on my line on my property, and so that's the only time ever in my lifetime that my landline has not worked. I think cell phones are less reliable than 5 nines. I don't know what the number is exactly, but they're not quite as reliable as landlines. So the phone company goes to a lot of effort to get 5 nines, and a lot of the services are in the cloud are measured in 2 nines and 3 nines in that area. And if you want to get to more than that, you have to start then engineering for higher availability. Okay, so, but if you see, like I said, that's a tip off, that's a spanner tip off right there. If you see this very high requirement for very high availability, if you see horizontal scaling of a DBMS, of a relational DBMS, that's a spanner tip off phrase, because there's basically no other product that does it, or very, very rare that any other product can horizontally scale. Traditionally, most DBMS have scaled up by scaling up. And if you're looking for low latency global writes, you should automatically think about spanner. The word global is the tip off here. If you're looking for a globally consistent, I won't say too much about this, but if you're looking for ACID, which means high consistency and global, you're automatically thinking about spanner. So we'll come to that later, but just to give you a preview of those points. Again, going back to a Google slide here, different options to run databases on Google Cloud. I think you've seen this already. I've talked about it in previous weeks. I think you saw it in, it was very clearly laid out in the labs, or also in the video lessons, right? You have the trade-off here is that you have on the top, when you have Compute Engine, Google Compute Engine, you can run any software you want on Compute Engine, right? As long as you can install it yourself, you can run it there. You have to do the patching. You sometimes may get an image that is preloaded with something with like SQL Server. You get a Windows image that already has SQL Server built in. That gives you the most control. If you want to run a little more efficiently, you can run inside Kubernetes in GKE, right? Google GKE is Google Kubernetes Engine, right? It's a managed Kubernetes service, right? You can sometimes use Helm, deploy those databases in Kubernetes. We had an example of how to do that in one of the labs. If you then want to give up a little more control and you want to do less administrative work, you can go to the bottom part of this slide. Cloud SQL gives you these options where a lot of the patching is done for you. You're always on the latest version. You're always up to date with security patches, things like that. But you do give up some control. And so those are your, sliding scale of trade-offs there. You do get, like this third point is pretty significant, where configure backups, point-in-time recovery, read and failover replicas. It's very much, if it's not completely automated, it's at least a paved path, or there's one prescribed way of doing it, so that you don't have to become an expert DBA on every database server that you're running. You can just offload a lot of that effort to Google Cloud itself. Okay, so, the famous Oracle bare metal solution. I think we've already discussed this at great length, but what I think that the point of this is that if you want to run Oracle databases and Oracle business applications on Google Cloud, you have to run it on approved hardware. Oracle won't support it on commodity hardware that is different from cloud provider to cloud provider. So if you look at it from Oracle's perspective, they want to run their software on a known set of hardware or a small set of different hardwares. And that's why whatever hardware it is, it needs to be certified and optimized to run that workload. Now, you can also run older versions of Oracle databases. That can be important if you have applications that can't be upgraded easily. Large enterprises have big apps that run for decades, and it's expensive to modify them, and it's not always feasible to update to the latest database server, which might have new features or other desirable properties, but it's just too difficult to upgrade. And just think of all the COBOL that's still running out in the world that runs a lot of businesses. So So I think we got the idea here that this is, it might be a good path to migrate an Oracle server, Oracle software to Google Cloud. What you have to do before, until now, is actually use this bare metal solution that has this very difficult lab associated with it. And if you don't want to run the lab, I completely get that, but I encourage you to read through it so you understand what's involved in running it. Now, we've called out already previously that there was a product announcement on June 11th, and I've given you the link for it. This will probably not be on the exam. I can't see how they would update the exam for this, but there is something available today called Oracle Interconnect for Google Cloud. That's improving the networking options between Google Cloud, other Google Cloud products such as GKE and Compute Engine. That connectivity to Oracle's now had gotten better. I think the egress charges are being lowered as well. I don't know the details of that offhand, but it's potentially very significant if you can lower egress charges or remove them. And later this year, there's something called Oracle Database at Google Cloud. My understanding is that they're actually going to bring Oracle approved hardware into the Google data centers at that point. That's not quite ready, but it's coming this year. So that will remove a lot of the tedious steps of this bare metal solution. And however, I think the lab is going to still, if you get any Oracle questions on the exam, it's going to be on the current, as of 2 weeks ago, that solution, and that's what the lab is focused on. So I think we said enough of that. Just the ideas here. One of the big drivers, for example, of running a big Oracle database, what's on premises or in Google, is actually SAP. SAP is, ERP, enterprise resource planning, and accounting software that's used by a lot of large enterprises, and it requires a very reliable and robust database at the back end. So that often has been Oracle. I think there are some other options. SAP, in fact, bought Sybase, so I think there are some other options within SAP databases also, but running SAP on Oracle is a very common thing to do. And what is evolving now is that, I don't know the detail of this 2x license fee penalty, but it's, if you run Oracle in Google Cloud, you can avoid that. I don't know the details of that, but it sounds like that would be very significant, actually, that the license fee on these things at scale, enterprise software at scale has pretty heavy license fees. So I'll say a word about RAC, Real Application Cluster. That is a way that Oracle somewhat did scaling out by adding a cluster, and Microsoft SQL Server does this also in some environments. You can add a cluster of servers, which is a scaling out pattern, but they're all working on one set of storage, on one set of disks. So it's not a true scaling out solution, but Oracle had this solution for quite a few years, probably more than 15 years, called RAC, or Real Application Cluster. That works pretty well, but that's all can be run in the cloud now as well if you're using one of the Oracle approved methods of running in Google Cloud. So this slide talks about, I think the point here is that different database options have different pricing models. Okay, so if you're going to run a fairly large database system in Google Cloud or any other cloud, what you want to do, probably before you migrate, as part of your planning for migration, you probably want to estimate the cost of running that solution. I recommend doing that over a 3 to 5 year projection forward. It's difficult to go out 5 years in advance. There's a lot of uncertainty in that, but even an estimate is better than just a guess. Okay, so there are ways of doing this. They're based on traditional database capacity planning methods that we've used for many years in our budgeting cycles, right? So we used to have an annual budgeting cycle, and we would think about if a database server was getting old, more than 3 or 4 years old, we would think about replacing that or upgrading it. If we were hitting capacity limits, we would think about upgrading it. So we do have standard methods for doing capacity planning, especially that's just one of the things that database administrators do, right, is make these kind of calculations. It's important to do that in the cloud. I happen to be a FinOps expert, so I know a lot about cloud FinOps. It is not a good idea to just build a solution and then say, oh, let's add in the cost management part at the end, just the same as you don't add in security at the end after you've built everything. So you really need to think about the different cost models as you're going into this situation. It might, in some cases, tip you. If you have 2 possible solutions, the cost factor might tip you one way or the other. Like, for example, I've already mentioned, let's take Spanner, for example. Let's just drill into Spanner here for a moment. What is its cost model? Well, you're charged by the nodes. You're charged for storage and nodes. Okay, so nodes are, you have a Spanner consists of a cluster. You can choose where in the world, those nodes can be anywhere in the world. You choose where they are and how many of them there are based on your read and write requirements. Your storage is driven by how much you're storing and whether you keep data there forever. Do you roll it off after a year? All those kinds of considerations. So those are all the things that DBAs think about. And then again, is it regional versus multi-regional? Regional would be, like I said, within one part of the US. Usually if you're looking at Spanner, it's very often going to be a multi-regional or maybe a multi-continent situation, as it is for Google. Spanner was developed by Google for their internal ad serving. and other functions within Google Cloud, and that's a global business, right? That's why they invested so much into making Spanner. But you can go to the pricing calculator here. This is a live link. You go to the pricing calculator, you can plug in some numbers and come up with some estimates. Now, I've already hinted that if you're at low volume, the minimal cost of running Spanner is pretty significant. So it's not a small thing, it's a very powerful thing, and you want to take a look at that minimum cost if you're at the kind of the low end. If you are at the lower end, you're probably looking at Cloud SQL here as an alternative. So this would be a place where you'd have, okay, I know I need, I know I want to manage service. I don't want to do my patching. I don't want to worry about all this. I don't want to worry about the license. I don't want to worry about figuring out how much RAM and CPU I need. So I want some kind of a managed service. So I'm choosing between Cloud SQL and Spanner. That would be a great time to consider what you need for high availability. Is it zonal outage or regional outage that you're protecting against? That factors in to your design. Once you have a candidate design solution for, solution design, two alternative solution designs for these two approaches, go to the pricing calculator and factor that in as well. So each one of these has a different price model. If you're building compute, much more piecing together your own Lego blocks and figuring out the cost of each of those components. You can definitely do it, but that's how you go with this. Implementation methodology. These are advice given from Google that they've taken from their PSO, Professional Services Organization. PSO is now called Google Cloud Consulting. A lot of people still call it PSO. This is the advice that they've learned from working with a lot of customers doing migrations. So my take on this is that this is the technical steps that you have to do, but it doesn't really give you much in the way of planning and validation. And for migrating large enterprise databases, those are critical steps. If you have, let's say you are running SAP on Oracle and you want to migrate that to the cloud, that's a big undertaking. And you have to understand that your SAP system probably cannot have any downtime at all, or very, very little downtime. So that kind of project management and validation steps are not really on this. So this is kind of a limited scope of the technical requirements. And that's a lot of the labs are focused on technically how do you move data from on-premises to cloud, or how do you do this migration with this product or that kind of thing. So there's not, I don't think the labs cover the really big picture, which on a big project is a big part of the work. There's a lot of planning that goes into these things. So I think this is self-evident for what it speaks to, but it doesn't cover everything that you'll need to know about. So I'll come back to that in a little bit later. But they've also added in here, there are certain migration tools that the PSO has worked out. Migrating from Oracle to Postgres is one area where there's a migration product. Now, in this case, they do actually go to assessment planning and testing and optimization. So that's what I'm saying. Those pieces on the left and right were a little bit missing from that prior slide. So if you're doing this whole project, this is more what it looks like. So schema conversion, data migration, code conversion. These are the hardcore technical steps in the middle, but you've got to wrap that with a lot of planning. And so there are some automated schema conversion tools. The reason why this one is called out separately is because it's a fairly common migration for people who are running Oracle databases and don't want to be locked into using certain hardware, very specialized hardware that Oracle runs on, or they don't want to pay the license fees for Oracle going forward. They want to switch to some open source system. Then you have to figure out how to migrate the code. So a lot of it depends on the schema. Migration is fairly straightforward. Most of the data types, they're not identical, but they're good matches for most Oracle data types within Postgres. And a lot of the work here depends on the complexity of the Oracle stored procedures that need to be ported to Postgres if you're going to port them, right? So you may say, well, I want to pull that business logic out and put it into a different tier. That's one approach. Or you could say, we want to translate our Oracle stored procedures to Postgres. There are some, I believe there are automations in here for doing some of that. I don't see them called out specifically on this slide, but I know that there's some. This is a well-recognized problem, and people have worked on this for some time. So either Google will have such tools, or there are parties that offer Oracle to Postgres stored procedure migration, which is rewriting the SQL, in other words, to match the new server. I think that some of the current generation of tools will be influenced by AI or assisted by AI. I doubt that AI alone can do this entire type of conversion by itself. I don't think you can take a big chunk of Oracle stored procedures and drop it in and expect to get a big chunk of working Postgres code out on the other side. I think it might work in many cases, but there's still a fair amount of work involved in doing this kind of work, this kind of project. So again, let's go back to strategies, start looking at some of the tools. Okay, these slides are perhaps not flowing perfectly from one to the next, but these are the Google supplied slides for this week, and they're all making very good points, so I'm just going to talk about them as they come up. I did reorder them to some extent, but to me, there's a little bit of disjointed nature of this presentation, but bear with me. The site reliability engineering techniques, or SRE techniques, are something that the cloud providers have pioneered, especially Google. Google has, there are two so-called SRE books that are published by O'Reilly. I think they're both written by people at Google. Certainly the first one is. I've not read the second one, but I know there are so-called two SRE books that you can find at O'Reilly. And the idea of SRE is that if you have a development team that both builds things and runs their own stuff that they build, right, you have to sort of make a dividing line between how much effort are you putting into development and how much is ops. And one of the key ideas of SRE that Google pioneered is that you have an error budget. If your errors or bugs or problems as you're running in production, if those become over your budget, then you take people from the dev team and move them over to ops, and you therefore slow down your release of new features because your dev team is smaller, and you've increased the size of your ops team so that they can fix those problems that are coming up. And so by managing this well with an error budget, formally recognizing an error budget, and then using this feedback mechanism, you can achieve the correct balance between dev and ops. That's my nutshell version of SRE. There's a lot more to it than that. That's why there are 2 books written on the subject, at least 2 books, right? That just from Google authors. There are a lot of other books on this, but some of the techniques that have been worked out, this is not particularly exclusive to database work, but it is in general how you migrate from one version of an app to another version. So the 2 approaches are the so-called blue-green deployment and Canary deployment. So in blue-green, you build a new version of something and you get it ready, but you don't turn it on until you're ready to go, until your release date, right? So you're still running blue. All your traffic's going to the blue environment, but you build up the green in the background. You're doing your development and testing and QA work on the green environment. And then when you say, okay, everything looks good, you cut over all at once. So you cut over, you flip a switch and you send traffic to green now instead of blue. Blue is still sitting there in the background in a hot standby mode in case you need to roll back. But if everything goes well, you leave them both running for a short time, and then you say, okay, we're done with blue. We can tear that environment down. So that's how it's done in general in the cloud. When you move from one version of an app to another, like I said, it could apply to Kubernetes pods. It could apply to running an app on App Engine or VMs, anything. It can be managed in this way with blue-green. So when you come to database migration, it becomes a little more tricky because now typically we'd be talking about one environment is on premises, the other one's in the cloud. So actually the differences are larger than you would typically see just in making a new release of an application. But this is the basic idea of it. On the right side, we have so-called Canary deployment, where we run both environments simultaneously for a while, for a period, maybe weeks, a couple weeks, and we gradually move the traffic from one server to the other to see the performance. How does it perform well? Is everything working right? Are there no errors? Is it handling the traffic well? Mostly the errors are what we're worried about. So if I look at these 2 patterns, so Canary deployment is used very often in web server farms, right? Where you, it's a way of putting a little less pressure on QA and building out a new environment. It's almost like you could have a feature toggle kind of system where you have a second set of servers where you turned on the feature, and Google has built in to the load balancers a way of automatically sending traffic, sending most of it to one pathway and sending smaller but increasingly larger amounts of traffic to the other server, to the new version. And so it's a very nice way to handle web traffic. I would say, from my experience in database migrations, blue-green is much more common, because if you start having 2 environments running, you have 2 databases running, as in a Canary deployment, you then have 2 different databases, right? And you've sent some traffic to each, and it's going to be hard to reconcile that at some point. It's not, if you have a database server or a database, right, that represents your customer traffic or your customer web orders that have come in, it's not particularly convenient to split that across 2 databases and then reconcile it, reconstruct it or rebuild it, reconcile it all, and getting it back into one. So it's not really a smooth transition, in my view, as it is with blue-green, where you do a quick cutover and if everything works well and you've done enough testing, it should work fine. And then once you're over there, you stay there. You have one database. You then can turn off the blue when you're done. Either way can work, but for database work, I'm thinking blue-green is more common, more typical. I do want to point out that operating in the cloud is an ideal environment for either of these approaches, because with blue-green, you have the transient need for two entirely different sets of hardware, right? And the same in Canary, you have two sets of hardware that you're running both of them for some period of time. In blue-green, you need the two sets of hardware. You're doing a quick cutover from one to the other, but you still need two. You need the running one and the one that you're building. So you need two sets of hardware. If you're doing all of this on premises, that means you have to commit to buying that hardware and having it around. And then when you cut over, let's say you cut over from blue to green, then you've got more hardware than you need, really. So that, to me, is one of the main benefits of using the cloud, is this kind of deployments become more cost effective in that way. There are different tools from Google partners that can help you in your, I would say, in the both in the estimation and project management aspect, and also in the technical moving of data. And the one on the left is called MigVisor. MigVisor helps you understand, helps you choose the right product that you want to move to, and gives you some advisory idea about assessing what it is you're moving. I haven't used it myself, so I don't know that much more about it than that, but it is a Google partner. I think it's probably a good product and fairly easy to try it out. With Stream on the right, we've had one of the labs uses Stream to do so-called online migration, which means really creating a replica of a target database. I don't remember if, I mean, replication works easily from like to like if you're going from SQL Server to SQL Server. I don't recall if Stream, some of you may have just done the lab recently. I don't recall if Stream does any to any. That would be probably the ideal situation, would be like, I want to migrate from MySQL to Postgres or something like that. If a tool like Stream could help you with that, that would be a big bonus. If anybody wants to throw a comment in the chat on that, otherwise I'll move on. I think it does. I want to say that it does do any-to-any replication, but I'm not sure, and I don't think that's what is done in the lab in this course. So let me go on from there. But this is more in the vein of the different models of migration, right? You can say, I want to do a lift and shift. I would just want to get to the cloud, but I don't want to simultaneously take on re-architecting my code base or refactoring my code base. I just want to get to the cloud so I can shut down my on-premises data center. This is often regarded as kind of a cop-out, as kind of a less than optimal way to get to the cloud. I actually don't agree with that. I think I think the criticism comes in when people say, okay, all I have to do is move everything to the cloud and I'll get all the benefits of being in the cloud and I'll save money also. That doesn't usually work out that way. If you're just thinking of moving and then that's it, you probably will end up spending the same amount or more in the cloud. than you were spending on premises. So the point of doing a lift and shift migration is that you get to the cloud in step one, but you still have more work to do. There are additional steps you do after that to refactor and change your applications to a cloud native architecture. That's what really gives you more of the benefits of being in the cloud. So that's what this slide is addressing here. It's like, if you have a big monolithic application with one single database backing it, it's probably a relational DBMS, right? Especially if it's an older application, older monolithic application. If you had to pick one database, it probably was going to be a relational type, because it can handle most data types. It's just not as flexible as the newer NoSQL data stores. Okay, so what this is advocating is, when look at your monolithic application, you're now going to, once you move to the cloud, whether you do lift and shift and then refactor and re-architect, or you do it all at once as you're migrating, you're also refactoring. You can do it either way. Your refactoring, your re-architecting consists of breaking the monolith into smaller services or microservice, what they call microservice bounds here. And it's common in microservice approach that each microservice will have its own data store. So it could have its own database. Once you make that decision architecturally, you're then free to choose the best data store for that microservice. And then depending on the type of data and the type of application, you may choose a different storage than you had before. Now, these are wildly different types of storage here that are given as examples. Okay, so if you have, it is possible that you could have had binary data stored in tables. It's not a great design pattern, but Oracle, Sybase, SQL Server, and Postgres at least, and others probably as well, have had the capability of storing blobs inside the database. If you have a traditional row store database, you can't store a blob. When you get into the physical storage on disk, you cannot store a blob, which could be, megabytes or more. You can't store that in line with your data rows. It just will mess up the whole pattern. It will mess up your indexes. So what you have to do is store the blob somewhere else in a source space that's managed by the database, but then give a pointer to it and do it that way. What this is advocating is move those blobs out of the database entirely, put them into Google Cloud Storage, and then just have pointers to those to cloud storage. I'm all in favor of that. It's a better solution. If you are storing essentially files or large, blobs, so-called blobs, put them in cloud storage. That's the most reliable, the cheapest. It's the best way to go. Likewise, web app and session data is very effectively stored in Firestore, which is a NoSQL style database. We don't actually have any coverage from Google in the labs of Firestore. I'm going to add in some material, not sure which week, but I'm going to add in some material on Firestore. It's a very interesting product from Google. It's very important for these web apps, but there's no coverage of it, particularly in this learning path, okay? As we mentioned, OLAP is analytical data, typically large data volumes that need to be scanned and aggregated and filtered. We do that in BigQuery. We've already mentioned that we don't talk much about that. And that leaves finally the transaction, which would be a good fit for Cloud SQL. If you have big volumes, you'd use Spanner for that. We're estimating that we're a little behind time here. As I said, there's a lot of material here. I'm going to try to go quickly through some of this and then leave enough time for the sample questions. So networking is obviously important anytime you're in the cloud. I think that the point that I want to make here is, first of all, if you're in a large enterprise and you're doing a large database migration, you will have dedicated networking people who will help you with this. So the point for this learning path is to know that the basics of VPC networks, these are shown here as VPCs. If you're not cool with this, go back to the course 1, the core fundamentals course on infrastructure. There's enough in there that will get you going on networks. Just remember, in Google Cloud, networks are a global object and subnets are regional. And that's different from other cloud. That's very different from other cloud providers. So that's a key point. You probably, that could come up on this exam, even though on the database exam, you probably should know at least that much about Google Networks. The other big point here is that we typically want our database in a private network, in a VPC. It could be in its own VPC. It should be on a private network. It's protected from the internet with firewalls. And this talks about the details of firewalls. You have allow, deny rules. I don't want to go into a lot of depth here. The rules are the default rules are fairly logical. Remember that when you create a project in Google, you get a default network that already has firewall rules built in. If you, in a production environment, you would not use the default network, you would create your own. It could be an automatic network. Even if it's a private network, you should not use the default network typically. When you create your own network, you have to then create your own firewall rules. You don't get any default firewall rules when on a new network. And the other point, firewall rules in Google Cloud are applied using tags. It's a very convenient and easy way to manage firewall rules. Works really nicely. I think this is easier and better than the way some of the other providers do it. So it's good to know about that. I won't go through this. I think these are bullet points that you should review. The top one is the network that's all zeros means everywhere, meaning source can be anything. That's something you should be careful about using. You normally want to restrict access to those IP addresses that need it, right? And that's just a principle of least privilege. You know, you should not just open everything up, and you want to lock things down appropriately. So I won't go further into that. Again, this was mentioned, we have private IPs, public IPs. This is so Cloud SQL allows you to create a database with a public IP. You typically would want to have your database in its own private network and then connect to something else as a client, and then use that client to establish a database connection in a secure manner, and then the database would be protected by the firewall. And that's why you have this on the top. You have the private IPs that you can associate with a network inside the VPC. Yeah, this again is more details about peering. Don't think we need to drill into this right now. Yeah, if you do choose to have a public IP, you then really should have firewall rules that lock it down to, maybe it's your corporate network, or It's generally not a great idea to have a public IP on a database that's open to all sources. That's usually everything in the cloud is being probed. Every IP address, every port. Just think that it's being probed all the time for vulnerabilities, and so you would still have a database connection string here and a user ID and password, but that is really not sufficient protection these days with the amount of probing that's constantly happening in the cloud. So you need to be careful with this when you have public IPs. Lock it down to your specific incoming addresses or a range. A little bit about my SQL Server options. Let's see here. So we've covered this a couple times now, is the trade-off here between running SQL. So this is specific for Microsoft SQL Server. You can run it on Compute Engine, you can run it on Cloud SQL, you can run it in GKE. And we had 3 labs that showed you how to do each one of those things. And again, it's a matter of trade-offs. How much control do you want or need? How much, do you want to give up patching? Probably yes. If you don't have to patch it, don't do it. But if you need complete control over all SQL Server features, you probably need to go to the left side and go to the Compute Engine. There is I have a link. I'll put it in Slack later. There's an actual link that says which features are specifically allowed for SQL Server in Cloud SQL in the middle of this slide, right? Some of the limitations come from the fact that SQL Server in Google Cloud runs on Linux, and not every feature in SQL Server actually runs on Linux. So that's part of it. I think there are also restrictions that come from other reasons, but it's well documented, and as Glenn said a couple of weeks ago, it's easier to remember the things that are enabled rather than all the things that are disabled. And I'll give the link in Slack after this meeting. I'll update that and let you know where to find those details. Data migration services. Here we have a couple of products from Google. The idea here is that these are tools that follow a low-code development approach or no-code approach. So they have a nice GUI interface that can be used by business analysts and certainly could be used by data engineers, but not everything in here requires a data engineer. So in other words, some of these data pipelines can be built in kind of a drag and drop manner, where you select a source, you have a plugin for that source, you can build test and debug pipelines, and really think of this as a graphical interface over a code generator that then is running your pipeline in the background. And so there's a pattern here that we see that Google has made a lot of effort to. Google is fundamentally a very engineering-focused company, right? A lot of the data engineering and database path is about learning different ways of coding things with Terraform and other methods, but strong SQL. But there's also, in this path and also in the machine learning path, there are a lot of options for low code and no code approaches to the same problem. So this is one of those examples. This one, I think, actually is an interface on a product called CDAP, which is the Cask data product that I think Google bought this company. So that's where this came from. Cloud Composer is an orchestration tool that lets you create so-called DAGs, right? Directed acyclic graph. A DAG means think of it as an execution graph. It's really just starting from here, do these steps. You can run some of them in parallel possibly, but the acyclic part means there's no looping back to the beginning. There's no looping back to an earlier step. So that's what a DAG is. DAGs appear in a lot of places in Cloud Composer. Cloud Composer is I'm blanking on it. It's a managed service that
it's
is
Airflow.
Airflow. Thank you. I was blanking on the word Airflow. So there's an Apache Airflow project that is an open source project, and this is a managed service version of that. So it's very effective. It works well, but the fundamental idea here is you're building a pipeline using a DAG. DAGs are good to learn about because they appear in TensorFlow and other places. And so some people call Cloud Composer an ETL tool. I don't see that myself. I don't quite know where that came from, but I think of it as it's really an orchestration tool that is all about managing different pieces of your pipeline and running them all together as a group, as a unit. Okay. Okay, so we finally made it to the sample review. We're a little bit late on time, but I wanted to get this in maybe overflowing 8 o'clock just a little bit, but not terribly too far past 8. So there are 3 questions here that Google provided for this learning path. Jessica turned these into a Slido for me. I think this will just show up on the Slido. Now, Jess, what do I do here? I click on the top link here on this top button. Uh-oh. Well, I'm going to try it. Now this is giving me just a general link to Slido. Jessica, are you still there? Did we lose you?
Yeah, I said you needed to install the Chrome extension or present with Slido.
Oh, okay. I thought that was, it said or install. So I thought that was one way to do it. I didn't realize I had to do that. So let me pivot to the doing it the other way without Slido. I'm sorry, we're still rehearsing our Slido techniques here in real time. So let me go back to, well, these are the, this is the question. I need to jump out. I'm going to unhide the slides that you hid and reveal the questions that way. Unskip. Okay, no peeking now. No peeking at the answers. By the way, while I'm doing this, I'll just mention to you that I'll tell you how I did on these questions at the end, but I don't know if these are the right questions for this learning path, honestly. I just, they don't seem to tie to the database material, but let's go through it. This will give you, I'll make some comments. We can tell you how to approach answering these questions. These are similar to exam questions. So this first question is, a customer is looking for a mechanism. Oh, this is actually the second one, sorry. Here it is. The following securities are part of 2 GCP security layers. So, and then it lists comma separated list of 4 features. So the thing is, the structure of the question is, there are 4 features here in the first sentence, and they are part of 2 security layers. And what are the names of those 2 security layers? So what you have to do is understand the relationship between RPC traffic encryption, so that's remote procedure call traffic encryption. Is that a part of one of these options in ABCD? And which one, in other words? And sometimes it's not always the case that these ABCD are always real. They can be sort of pseudo good sounding answers, but not actually existing in reality. And this is before Gen AI, right? Several of us have studied these. This question came up in one of our earlier learning paths, and this was before Gen AI. So I'm not claiming that there's any hallucination going on here or anything, but we've definitely noticed, typically these are real options that do exist in Google. Sometimes they'll throw in something that doesn't even exist. So I will be silent for a minute to think. Okay, I'm just watching the chat here. I agree. I think maybe these are security. These questions got pulled in from the security learning path. I don't think they apply to the database, but nonetheless, let's step through it and try to figure out how this might work. So I'm going to reveal the answer now unless anyone objects. Okay, I'm going to go ahead. Oh, Jessica has to stop. So she's going to drop off in a moment. Okay, so I'll carry on. And this is being recorded, so any of you can follow through later if you have to stop at 8. So the correct answer is service deployment layer and internet communication layer. These are the names of the two security layers. Now, I didn't get this right, and I'm not particularly familiar with this area, and I'm not a security expert, and I have not studied the security learning path. So to me, this seemed like foreign material. But what I did do is look this up, and I found that all of these options, let me go back to like infrastructure layer, security layer, service deployment, storage layer, and communication layer. Those are the 5 possible layers. They do all exist. All of these exist within Google Cloud. They are all actually all real things in Google Cloud. So if you know that much, then the question becomes, how do I map these features onto these layers? And so these are all real features. They're all real layers. So there's nothing like weird, really weird going on here. It's just that it's not a database related question. And so if you know this area, or you know security in Google, then you might have a better shot at getting answer C, which is the right answer. Now, I think I was able to eliminate B. The other approach here, if you don't know the answer, try to knock out as many as you can as impossible, and then choose between what remains. And so I didn't see anything here that had anything to do with storage. So I knocked out storage layer just on that. But fundamentally, I was left then to guess for the remaining 3, and I guessed wrong. So yeah, I'm seeing on the chat some some confirming ideas here. So good. So let me go to the next one. We'll see how I did with this one. So here is customers looking for mechanisms to control the amount of resources being consumed by a project in a way that does not go beyond a predefined monthly budget. And what mechanism would you recommend? In other words, you don't want to overspend a particular budget. How can you do that? And this is not a database specific thing. It's related to any service within Google Cloud. So this requires knowledge of the Google billing reports and the way that Google does billing. And so again, let's see if we can knock some of these out. So I happen to know this area pretty well. It's not a database related question. So again, I think it's probably the wrong, something taken from another learning path. But for billing account of the organization, there's things wrong with this. First of all, setting a budget does not stop you from overspending. It's just an alert. It's a mechanism for sending a warning. It will not prevent you. The question says you didn't want to go beyond a predefined monthly budget. So you have a hard limit. You want to stop before you exceed that limit. A budget will not do that in the way Google billing works. A budget is simply a warning. The other problem with this is that the billing account of the organization is at the very top level for the whole enterprise. So if you that would not granularity that you want at the project level. That would be usage for the entire enterprise, which would be your little project is probably down in the noise level of your organization or your enterprise budget. So that's the second thing that's wrong with this one, is that it's at the wrong level. I just realized I should go back to this other view. So A is wrong. Set a budget limit within the project that have to be controlled. Okay, that's better because it's at least at the granularity of project, but it's still incorrect because a budget will not give you a hard limit. C is implement a quota for the resources that are being consumed by the project. That sounds a lot better. So far, I'm liking that because at the project level, it's the right granularity, and it's also a quota will actually stop you from overspending. It's not just a warning; it's an actual stopping.
Actually, maybe it's important here that the budget they are talking about, is it a monetary budget or a resource?
Oh, that's a great question. That's a great question. I was thinking of it as a monetary.
Yeah, me too. And then if you define quotas for resources, how do you know what exact monetary figure that's gonna come to, you know? All right.
You're right about that. I don't think, I mean, you would have to know, you'd have to do the cost calculation and say, like usually for a database server, the running of the server is going to be the most expensive compared to storage, typically. So you could say, well, I'll get most of the cost. I mean, I think the way the question is written, though, it says, well, all of the answers refer to billing account, right? Or most of them refer to billing account. So that's why maybe when I saw that, I said, well, they're talking about money. But you're right, actually, this is not money directly. So you would have to figure out the cost of running the service and go from there. But then finally, let's go set up an alert with a usage threshold so the administrator can downsize. Again, an alert is a warning. It's not going to be stopping at a certain budget. So I think the closest answer is the C, setting the consumption quota. So I actually got this one right. That's their answer, is C. I got this one right, but I wasn't confident about it, and I have a fair amount of knowledge about the way billing works. And so to me, it's not a great question, but a lot of the others just don't fit at all. Like I could knock out a couple of these just by being at the wrong granularity. Then if you're not at the project level, you're not, definitely is wrong. So this one doesn't, this one does mention project, yeah. So the project grain and quota. But the thing is, I don't like this answer in any case because it's usually, I mean, if it's a development environment, you may do this, right? You may say, okay, I'm going to have a hard stop and then I'm shutting everything off. I'm going to shut down the service when I hit the budget limit. But you could do that in dev. But in a production environment, this is the last thing you want to do, right? If you're running, let's say you're running a database server and suddenly you got an increase in your business for 1 month, which is a really good thing, right? And then suddenly you had over exceeded your budget for the database because you're getting a lot more orders that month. The last thing you want to do is turn off the database in the middle of that in production. So I don't like this question and answer for a lot of reasons. But anyway, this gives you an idea of the type of questions. But let's go on to the next one. Sorry, an organization looking to segregate projects by development stage to better control different versions of the product. Which are the 2 roles needed for a user to be the administrator of the project? So the goal here is good. You typically want, prod resources and dev resources in different projects. In Google Cloud, it doesn't cost any more to have different separate projects. So administratively makes a lot of sense to do this. But the question is then, how do you achieve this? What 2 roles does a user need to be the administrator of each project? Again, if you don't know this stuff at all, it's going to be just guessing. I can tell you that there's a resource hierarchy, and that consists of organization, folder, and then project. And folders can be nested, so you can have folders within folders. But basically, you start at the top as a organization level, folder, project. And then, so possibly, based on that, if I need to be administrator for a project, I can knock out B because that refers to organization and folder and doesn't mention project at all. So I'm pretty sure B is out. Likewise, I'm probably going to get rid of A because it doesn't mention project at all. And again, I think I actually chose C as organization administrator and project creator. That sounded like it might be right to me, but in fact, the answer here is owner and IM admin. Okay, let me see if that's right. Yes, owner and IM admin. Now, when I did the research on this, I found the role here is actually called, so project owner, I get that, I know what that is. It's one of, owner is one of the primitive roles, and you can be an owner of a project. If you are an owner of a project, you can pretty much anything you want inside that project. IM admin is also called, it's really called, the full role here is called, this is not a basic role, this is a so-called curated role. So this is called, really, technically this should be project IM admin. Between these 2, you have the ability to move projects around within folders, and you also can then move resources into different projects. So that's the answer. Again, I don't think this has anything to do with databases, so I'm not sure why. I just think these are the wrong questions. I went through them. I just discovered that this afternoon, and so I decided just to present them as they are, and we'll try to figure this out by next week, what the better questions are. Now, I did not, let me see. Yeah, we're at the end. We're almost at the end. If people can hang on for just a couple more minutes, what I wanted to do was, let's see, I had the exam guide, for this learning path to show this for a moment. So this talks about designing scalable and highly available cloud database solutions. Yeah, well, that's what we've been about all evening, but these don't relate to this topic. And likewise, manage a solution that can span multiple database solutions. Well, we didn't go too much into the multiple database solutions, but again, these questions didn't relate to this. And then likewise, migrating data solutions. We talked about this, and the labs cover this extensively. These questions, again, don't really touch that. Scalable and highly available Google, databases in Google Cloud. Yeah, again, good topics that we've talked about all evening, but not covered by these questions. So I just present these questions as examples of what might come up. Now, I'm not saying, it's possible to get really any question. You could get a security question on the database exam, but it wouldn't be, I don't think it would be as difficult as that one. And I don't think it would be 2 or 3. It would be maybe one random question that they've thrown in from another area. So it's not possible that you would get it. The other thing I just want to, in closing up here, I want to mention that I want to make this point again, that the labs cover a lot of the technical details of migration. I think it would be good to go back to the video lessons and look at Module 1, which is one of the early videos, Module 1, and also Module 10 at the end. So the beginning and the end, and especially Module 10, which is building the business case for doing a migration. There they talk about the lift and shift approach, which is much maligned, but I think has a valuable position in terms of just getting the job done, getting over to the cloud, and then giving you a better platform to re-architect your application. I think lift and shift definitely has a place there, especially if you're on a deadline to shut down your on-premises data center, like if your lease is expiring or your hardware is getting old, things like that. There's a lot of pressure to just get to the cloud. So anyway, the beginning and end of the video lessons have what I call this project planning and organizational material that is very valuable, and it's not really covered in the lab. So I would recommend you go back and take a look at that. For next week, we are going to move to new material. So we're closing out Lab 3. I'll still take questions about anything next week. But please, wrap up whatever you can on Course 3 in the next few days. I know we have a holiday this week and so forth, but definitely watch all the video lessons and complete as many labs as you're going to do in Course 3. Do that in the next couple of days. Please begin Course 4, which is about migrating MySQL. So the next 2 courses are all about MySQL, getting from on-premises to cloud, and then the next course all about Postgres. So there are two open source relational DBMS systems, and you have a whole course on each one. These courses are these labs. So these courses are all labs, and these labs are more straightforward than the previous ones we've just gone through. So I think we've, if you're having challenge to finish these labs or you're finding them difficult, don't feel bad. Just try to wrap up wherever you are in Course 3. We're going to move on to 4 and 5. They should be getting more manageable, and as people get more experience, they should definitely be becoming a little bit less challenging than the one we just went through.